And good evening, good afternoon, good morning, everybody. Welcome on into the Dragon's Den. My name is Digital Dragon, aka Luke, and we're here today to continue working on our Micron build. We've got everything pretty much put together. We're in the final stages here. And by that, I mean we've got the frame all put together, we've got the gantry mounted. Now it's time to build and install the tool head, assemble and install the heated bed, and then set up our electronics. Now, as far as the electronics go, between the last stream and this stream, I have gone ahead and configured all the electronics, meaning I laid it out on the bench using a Raspberry Pi power supply into our controller board here and installed and configured our CB1 module. Got it online, did the whole 9 yards. What I do on CB1 modules is I install the base minimal OS, and then I use Kaya to install everything else to a Flipper screen, particular printer. We've also gone ahead and installed our PMC 2209s and the corresponding jumpers underneath to set them into UART mode, as well as, here, I'll flip over to the other camera. Between the actual steppers and the sockets, there are jumpers, and you can probably see them right here. There's jumpers right above the red portion here, and that sets whether it's pulling power from the board power or the bed power. So you can technically run these with a different power supply or a secondary power supply. Just be careful because of the capacitors on here. That's going to be your limiting factor. And I've gone ahead and pre-configured my 4 2-pin ports, jumpered those over to 24 volt as well. Now, whenever you're powering the board up using your 5 volt end through your USB-C connector, you must put this jumper in between the gigabit Ethernet port and your CB1 or CM4 module. So when you're done with that, you'll pull that jumper and you'll go back to getting power for everything from the actual power connector on the board. That's something to be aware of as well. I have also, so this is configured in USB to CAN bridge mode, meaning there is Catapult loaded on here as a bootloader and then Clipper installed, such as we will be using our CAN bus, which is these two 2-pin JST connectors, our CAN bus, and we do have the jumper in place for the 120 volt or 120 ohm resistor. I have also installed Catapult and Clipper on the EBB36 toolhead board and gotten that talking and working right. So I did that off stream just to make things a little bit easier. There we go. Hello, bottom right hand corner. Just to make a little bit easier once we get into this stage. It also helped that I was kind of going back and forth to make sure I had the right EBB36 configuration pins by looking at the salad fork. And I made the mistake of doing on the salad fork, said, hey, update all, because it's been offline for a little bit since the build. And then I got to go around and redo Catapult and Clipper on salad fork because it was also set up as a USB to CAN bus. And the version of Clipper on the host controller, once again a CB1, differed from the version of Clipper that was on the installed as firmware on the main board. So we had to reinstall Clipper. But welcome on in, Hybrid Robotics. Welcome on in, Aussie, and anybody else who's snuck in and hasn't said hi yet. I hope everybody can hear me and that we're doing good. Hopefully. You'll see there's a smattering of parts here. These are parts for our Mini-Stealthburner. I just realized that I am missing one critical part, and that would be the sled part that goes right in here with the hot end on it. Hey, Lucas Player, how's it going? So we can work on this and we'll get it assembled to the point where we install the hot end. And then we may jump over and work on the bed for a little bit while I'm waiting to print that out. Right now, all of the printers behind me. So Trident has PLA loaded in it along with a hot end that I'm testing under an NDA. Kyber Dragon has been printing out parts for a project. Let's see if anybody can tell what that project may be. This is black. I had a 3 kilogram spool of black, so I went ahead and used it. I will be spray painting this and with filler primer, sanding it down some, and then painting it in white and then doing the appropriate color scheme. But this is a 40% size mini chopper. So it's just the main body in the dome. And this was printed at a, what was it, 0.16 layer height, I believe. So I shouldn't have to do a lot of sanding on this. Filler primer should be able to do it. So this is the main body and stuff. The very last piece let loose from the print bed when it was almost done. What did I do with that? I don't know it. Oh, yeah. It was this piece. This is the door that covers the electronics. And it's only about like that tall. So it was almost done when it broke free and moved around on the bed. So not much of a contact patch down here. So I'm probably going to throw some mouse ears, or maybe I'll just bite the bullet and do a full brim on it and call it good. But we'll get this reprinted, and then this will be the last piece for the chopper droid. And I should be able to flip over from the black and go to the 5 kilo roll of white to start printing out all the white parts for the DO build. So, yep. And so once again, PLA. This has PLA in it because I'm still working on it. This is Fey Dragon. This is a printer. On Saturday, we swapped the gantry out with, it went from the aluminum extrusions to the carbon fiber kit from Chaotic Labs. And it looks great, but I'm going to have to check it out and really keep an eye on it through some prints, because as you've seen me post, I've had 2 catastrophic blob prints on it now. This being the second one that I had to heat the hot end up to 260 to get this to come off the hot end. It was fully encased around the Revo. How it came out without ripping wires off the ceramic heater, I don't know, because it still doesn't have a silicone sock on the ceramic heater yet. I thought I needed to order some, but I do have one that I can put on there. And I don't know. Both times when it failed, I was not up here. So I need to figure out if it's something where the gantry is twisting, in which case the carbon fiber comes back off, the standard aluminum goes back on, and yeah, I'll just be done with it. I'll give the kit away if anybody wants to try it. Yep. we'll be working on the Micron build. So basically what I'm getting at is the K3 is the only thing that's currently set up for a high temp filament, which you would need for a hot end mount going into an enclosed printer. So as soon as this print's done and it cools down enough that I can pop the parts, I will slice well, I've already got the slice or the part slice that I need, the 30-minute print. So it should still be done by tonight so we can mount it. We'll just work the tool head as much as we can and then move around. But I will say, when Fade Dragon is printing and I don't get the blobs of death, it prints beautifully. This is the Photos Mint Moon Dragon and Polymaker Starlight Comet. This is a beautiful print, very, very detailed. So when it prints well, but I just don't know why. I mean, I've had months and months of good prints out of it. I do that gantry and all of a sudden I've had 2 big blobs on it. So I don't know if it's a filament issue or what the deal is there. Yeah, it was bad. I don't know. That's the thing, is I have heard people say that they've had twisting and sag in the Chaotic Labs carbon fiber kit, but I'm not noticing it. And I'm not sure. Like I said, both times when the blobs generated, the first time was me being up till 2 o'clock in the morning, hitting send on a print and going to bed, thinking this is a known good printer. I just changed the gantry, no big deal. And it blobbed like all get out. So that was my bad. That shouldn't have done that. And then the next time it had laid down, it was printing fine, and I went downstairs, and then I heard some noise, and I was like, "What is that?" And I came running upstairs to find another huge blob. So, all of my Voron 2.4s and Tridents to date are 300s. Starting this Saturday, we will start my Trident 350 build. Zombie. And yeah, there won't be a carbon fiber gantry on that one. It will be the aluminum. Yeah, and like I said, Zombie, I'm not sure if it's anything to do with the gantry or what. It's just something I need to now start looking at to try and figure out what's going on. So today you're going to see me kind of hopscotch around a little bit. You'll notice that I've got a couple of apps up over here on the left monitor. For the printhead install, there, to my knowledge, is not a straight Mini-Stealthburner install manual. So the easiest way for me to do it, at least, is just pull up the V02 and do the toolhead assembly from there. So I've got that up here for that. For the Micron build plate, we've got the information on that, and really all I need is screw sizes, which is why I have this up here. We've already gone over, I've done all of the installation for the EBB and the Manta M8P board for this, but I still need to have the pinout diagrams accessible just to make sure that the pre-made wiring that came with it was actually pinned out correctly, because I have had issues with it not being pinned out correctly. So zombie, it would be interesting. And then the other thing I have is Fusion 360 up so that we can look at the Boop CAD diagram, because as we've noticed, there's no manual for Boop yet. So we will be going through and looking at the physical CAD drawing and looking at what size screws we need where and so forth as we start to put our tool head together. So I think what do I want to, yeah, let's go ahead and let's start off with installing the printer bed first. We'll get the bed mounted and all of the, we'll get the bed system put together. We'll get it mounted on the printer. We'll run it, run the wires through to the underside. We'll install our electronics and do some pre-wiring up on the electronics. And then that way we can start boop up after that because we'll have to get the heat set insert machine and stuff like that up here. So with that, let me jump over here. And our heated bed. So the way the heated bed comes, we have a Vividino. It's an AC heater, 110 volt, 180 watt. It does list that it has an NTC 100K B3950 thermistor. So that's nice that they actually put that right there on the heated bed. It does have the fuse in series or in line. So we will be able to take this and mount it to the bed, and then we'll have our thermistor wires and our heated bed wires coming down. And it does show one with the bare wire, and then the other one, and it has a link that says for Wagos. And the other one has the label that says for SSR and has your connector in it. So that makes life a lot easier. And I like that it's, even though it's all done up in crimp, they didn't mount it. Because what I like to do for my beds is mount the magnet first and then go back and mount the um the heat bed, because you don't want to push down on. So if this is mounted to the bed and then you go to mount your magnet and you're trying to apply your magnet with some force, you could actually crush the thermistor, which is in here, which is not a cartridge thermistor. Normally they're glass bead thermistor. So you can actually crush that by putting pressure down on this as you're trying to do the magnet. So I always like to do the magnet first and then come back and do that piece. However, if it is a point where you have a bed that's got a pre-mounted heating element, but you still need to add the magnet to it, physically mount it in the printer first, then do your magnet. That'll be the best way to do it in that case. So let's dig our bed out of its wrapper. Yeah, the 3D Chameleon, I keep seeing it and I see it in action and it's working well. But the people I've seen that have used the 3D Chameleon, a lot of them tend to complain about it. But it's just like everything else. Any MMU system needs to be tuned to the printer and the hot end. An AMS is pre-tuned at the factory so that when you get it and it's using its sensors, it knows the length. But if you're building a Chameleon, if you're building an AMS, you have to do some tuning. And if you don't, you're going to have bad or inconsistent results. You want to test the model. So I think I am out of touch with the conversation. Give me 1 second. So you made a speed quality test. Do you want to try it? Yeah, I would try it, Lucas Player. If you're on Discord, then send it to me via Discord. If not, do a bang Discord in chat, ! Discord, and it'll give you the link to the Discord channel. Or you can DM me on Twitter and we can figure out how to get it to me. Kit. Hey Aaron, how's it going? This is a Formbot kit. Zombie did the West 3D beta kit. Hey Aaron, welcome on in. Welcome on in. Yep, as I said, this is a Formbot Micron kit off of AliExpress. So I wanted to see what it was like. So far, everything's been decent. I mean, electronic wise, it's a Manta M8P with a CB1. It's got a Big Tree Tech, I think it's Pi TFT43 screen, Big Tree Tech EBB36 for the tool head board, pre-crimped wires, an actual Meanwell UHP 224 power supply. So everything's been top quality. An actual Omron, SSR, and metal backer DIN rail clip for it. So everything so far has been top quality. It had the, was it Vivdino, whatever that company is, Vivdino. It's, you know, it's a separately branded silicone heater. The rails are this same branding, but the rails, I mean, other than being bone dry when I got them, you know, greased them up and everything worked up. So oh yeah, Aaron. It's or yeah, Aaron F. Geared. If I was near West 3D, I'd be the same way. That's how I am with KB3D. Like I literally have two orbiter, you know, smart orbiter threes, a Leviathan, and a Revo Rotos sitting over here to go into projects that I have yet to define yet. So it's like I just need a line of credit that I just keep paying off at KB3D to the point where everybody's telling me like, stop saying you got a package. Just let us know when you didn't get a package. It'd be easier. So, so like everything else, we're going to clean it, but we need to make sure. So the standard size holes will be on the back. The holes that are counterboard, right, will be on the top. So that's where the magnet goes. So we'll start by cleaning this side off. And I'm sure Aaron's like that with Fabrico. Like, yeah, just pay me in printer parts or something. And I say pay me in printer parts because I think you support the shows and everything like that. So yeah, and then so far the only other thing that was kind of like a meh is the hot end. Now they do have options for an upgraded hot end option, like the Dragon, I believe, or the Dragon High Flow and stuff. And for giggles, I was like, well, let me just get their standard. Um, so this is their standard hot end. So take the sock off. Ceramic heater. Um, looks pretty plain Jane and basic. You know, just about everything's coming with the ceramic heater now. Standard, 104 NT4 thermistor, and it looks like the whole pattern lines up with the dragon. I also have a dragon and a dragonfly sitting over here, so if I put this in and it winds up being a brick, then I've got other things I can throw in here without batting an eye. So now I did just notice one thing too when I was looking at the magnet. Yeah, I expect this to print just fine with no issues. So, I mean, it's a 2.4 in a smaller package. The build plate, so the smooth side has a cover on it. That it's just, a protective cover on the smooth side and a textured side. The bed looks decent. I mean, it's not bad. I don't know who makes the bed for this kit, but I did just notice they've pre-punched all the holes in here. So make sure you line it up right, but you've got holes pre-punched. So as long as we get this lined up right when we get it started, all the holes should line up nicely. Yep. So that's nice. That takes a little bit more of the pain out of trying to get the holes done. Of course, like I said, you've got to get it lined up nicely, but it's also a pretty thick magnet sheet. And lay it down and make sure I line up the lower half, upper half lined up. Press it down, try and work out any air bubbles, and hopefully we don't get any air bubbles. Lift this up and pull it back a little bit by little bit. Continue to work it down and from the inside out. So I've kind of had a little bit of a mixed bag with some energetic beds. I'm not saying they're bad. I'm not saying they're great. I know some people have gotten some really good ones. But yeah, the build plate, it actually feels like a little bit better quality than the energetic that I've had in the past. Don't know if that means they're getting better or if this is a different one or what. I don't know. Like I said, it's not branded in any way other than the Micron logo. So Yeah, that's the thing is the smooth PEI side does seem like it's a lot thinner, but then again, I've been doing textured pretty much exclusively for a long while now. Um, the one um smooth bed that I tend to use is on the um 0G Mercury 1 downstairs, which is the Ender 5 size, Ender 5 plus size, sorry. And that's actually running the Honey Badger um, smooth PEI sheet, the P series smooth PEI sheet, which is a 370 build plate. And it's I believe that one is textured on one side, smooth on the other. And I've had stuff stick really, really well to it, to the point where I've been afraid that I'm going to rip it trying to get stuff off. But it's always popped off. Okay. So we got the front side. This is the back side. Same type of thing. Now this is not an edge to edge either. This is definitely going to be, a lot smaller, which is funny that they've got the little cutouts there. But yeah, this is definitely not an edge to edge design here. So that, just be cognizant of that because your main heat source is in the middle. Your edges will be colder. So when you have a printer like this that's not using a almost edge to edge design, just be aware of it, be cognizant of it. And you may want to heat soak that printer longer to allow that whole bed to come up closer to temperature. I can sit here and get really, really anal on placement and got to be a certain distance and you can mark out your plate and everything. Um, I didn't. Not saying that that would be a bad thing. Um, this does have a 3M sheet on it, I'm pretty sure. Yep. This is a 3M 468 MP adhesive sheet. So I am not going to worry about doing like RTV around all the edges and stuff like that. I do have it. I could do it. I may do it later. But also I'm not planning on running this stupid hot. Like I don't plan on going, oh, well, let me crank the bed up to 120 consistently, add a chamber heater and be sitting here printing at 90C or in a 90C chamber the whole time. So I think we'll be fine and won't have an issue there. So these are my 4 mounting holes, which means either one of these I would be able to bring my thermistor up around and mount to. So I'll need to do that. See what would be the best way. Maybe do something like that so the whole thing is actually on the bed. I'll go ahead and figure this screw out. Of course, it doesn't say, but it looks like it's going to be an M3 style. Yep, prep. We're going to go with an M312. So Aaron, how's it been going with your Micron? And I'm trying to remember, did you do a Micron or a Micron Plus? So Micron Plus, nice. And what was the tool head you did on yours? I know Zombie's pretty much making everything Dragon Burner. I know people are telling me, or at least I had one person tell me not to use the Mini-Stealthburner, but just to go to Dragon Burner. Swapping to Rapid Burner, yeah. So what I did here, this is a M3 hole size, so I put an M3 screw in there and then added a washer as a little bit of an extra lip to it. Make sure I was able to hold that down. You want to be careful. You don't want to crank down on this too much because then you could um, crack that ceramic fuse. And you might want to put Loctite on this because you're metal into metal. And it's going to be metal into metal on a piece of metal that's going to continuously heat up. So do some Loctite. I'm using an M3 by 12 screw. Looking at it, you could probably easily get away with an M3 by 8 here. Um, Dual 4010s is the minimum. Getting Zoll parts set up for your 300 Trite to swap out. Stealthburner Revo for Zoll Dragon UHF. Okay. Yeah, so Zombie, I've got that one hot end on my Trident over here. And the plan is to swap the Revo back into that one, and then the hot end out of there will go into the 350, probably with a 0.6 um, TC nozzle from Fadus. Okay, so that's installed. On the other side, we will need to install a ground wire, and not sure if there's one actually in the kit. We'll check it real fast. If there is, we'll install it. If not, but like I said, the wiring kit, am I impressed with it? And the fact that clicky, X in stop, we've already put the Y in stop in, Z motor wires, part cooling fan. So this will take the 2-into-1 on the part cooling fan at the back of the tool head. The X motor, Y motor, power supply to main board. This is our pre-made CAN bus for the tool head. And then AC parts. So we've got a SSR protected earth, Dewego protected earth. SSRL to Wago 413L. Okay, so there's protected earth and the load to the Wagos. SSR protected earth to bed protected earth right there. They've got all those cables pre-made and pre-labeled very nicely. So that's pretty That's pretty cool. SSR protected earth to bed protected earth. Now, what I would do is your crimp terminals are a little bit different. The blue one I would put at the SSR, which has your logo of SSR protected earth to the bed. The smaller one will go on the bed because it's got that M3 screw. So we'll make sure and get this mounted in that M3. I'll just use an M3 by 8 or hell, even a 6. Anything massive. Hey, Kit Skyfire, how's it going? Ooh, that's a good question, Aaron. I'm not sure which one either. Get a little bit of Loctite. I don't want to coat all the threads because I still want electrical connectivity here. But just going to angle this around so it can come right down with the rest of the wires when we put it on the printer. So fuse is mounted, our protected earth or ground is mounted. There's 2 other screws that come in here. They say to use M3 by 12 button heads and go in from the back. And these will basically form alignment pins for your build plate. These will actually go all the way through and stick up a little bit in the back. Just be alignment pins in the build plate. Recently home from work and still decompressing. I hear you there. I've been doing performance reviews for work, and I mean, luckily all my people are performing well, but we also had contract position that we had to, nothing wrong with the individual. We're having to swap the position for a different skill set based on the work that we have to deal with now. So it just sucks having to tell somebody like, hey, we no longer need your skill set. You didn't do anything wrong. You did everything we asked you to do and more, but we need a different skill set for this position going forward. You know, that kind of sucks. So that's some emotions there, you know. Okay, so I think our build plate's done. That sticks up a little bit. Magnet is on. Everything's ready to go. Get that out of the way. Right over there. Grab this wiring. Kind of put it aside for now. We will be digging into this here shortly. Okay. Set that right there, and we'll grab our printer. You may want to double and triple check my spacing of the back here, just because I think I am going to be rubbing on, the belts on the side. Adjust this back piece some here a little bit later. For now, let's see about raising it up. Of course, why does it not want to move? All right, it's going to be painful just to be painful. Bed mounting, bed screws. We should have our 4 M3 nuts in there. And we need our thumb screws. In this case, I believe that they provided Bakelite. Give me 1 second here to find them. There we go. They provided some, I think they called them Bakelite spacers rather than the standard metal ones. And I like that idea because with the metal ones, you're going to transmit heat through them, where this will provide a little bit of isolation between the metal material. The only thing that can conduct heat down into these frames then will be the actual screws. So, how you doing there, Royal Nomi? Hope you're doing well. Hope you're doing well. Black and white and red all over. Oh my goodness. Good one, Kit Skyfire. Gonna go ahead and get my screws knocked forward. And I'm going to try and get the front 2 screws started. And then we'll come in and locate the back 2. And we're going to use M3 by 16 socket head cap screws. So in front of the bed, rear of the bed. Oh wow, twofer. That's almost a new one. That's a new one. Okay, just trying to get these lined up, and like I said, getting them in there. I might have to do these last 2 one at a time. Oh, and then we'll work on squaring it to the frame and setting it to the right location. All right, we got all four. Now well, that's interesting. Let's jump over to the other version of the manual and see if it actually provides a location for the bed, because that did not have a location for the bed. Going to page 4. Called heater, physically on the bed. Are you serious? We just going to set the bed based on the tool head or what? Lots of running today. They got you up and running now on that knee? Okay, let me check something. 66, we need to let that. Um, so zombie, do you know if they gave any measurements for how far from the front the bed should be? Or Aaron? Or could either one of you maybe measure real fast what the distance from the front should be so that we can set our bed in the appropriate spot? Yeah, I know it needs to go a little bit forward where it's at because it's over the hole, but we'll take our wires and slip them down in the deck panel. Okay. Move the hot end over the bed and tighten. Yeah, that's what I was thinking we were. Which means I need to get the hot end on. For now, just going to tighten the front left with the appropriate size driver so that I can actually turn the screw. There we go. Just to keep it from moving around on me. In fact, I'll do both the front. And yeah, let's now that we got that done, let's go ahead and work on boop for a short bit, and then we'll come back and do some wiring. Yeah, because I want to try and do most of the wiring at once rather than doing it partial here, partial there. So let's get our tool head built, and or at least start working on getting our tool head built. Move this stuff out of the way because we're going to put in some heat set inserts to start with. we'll have to look at a couple of different places for the heat sets. One will be on Boop itself. So rather than showing you heat set insert, I'll show you what I'm doing to try and figure out where I need to put heat set inserts. So from a Boop standpoint, there's a couple of different places that we're going to have to put in some heat set insert. We've already got heat sets in this bottom carriage because that's where we've actually installed the X carriage to get the AB belts going. Yeah, they go in the heat set hole. So on this top piece, we're going to install these rear two heat set inserts here. And when you do these, you've got to really gauge the angle that they're going in and try and make that angle correct and consistent. If you mess up the angle now, it'll be a little bit more of a pain later on. And then where else do we have heat? So what I can do is come down here and see where our threaded heats. That's the, those are in the X carriage. That's one under the bottom one to make the pop out. So we'll have them in the side magnet holders. I want to say there was another set. Oh, that looks like a heat set right there, does it not? Topic screws for the micro switch. Going into the carriage. These come in from the angle and that holds this together. These two are going in from the front. So this part has to have heat sets in it. We're going to put heat sets in it. Because these are the two holes that are actually going to hold the tool head onto the sled that makes up boot. So heat set. Very nice. Now what we'll do is we'll take a look at our mini stealth burner and figure out where we need to put heat sets in here. All right, Roland, let me go grab dinner. Take your time, go slow. Oh, gotcha. Doing pre-op stuff. Good. Gets the story, Bob. Yeah, best guess for now. Yeah, that's pretty much what I did. Is just set it in place and said, okay, we'll adjust later. I need to also put in the ones on the side on our magnet holders. Be fun. Let me see if I can burn myself here because I've got a hole there. I guess I can put it on this. There's a part of me that was wondering about just using the older part that I actually took off the 2.4 when I took the printed tap off. Like, I'll just use the other parts. They're already heat setted and got the magnets in them. And apparently I decided not to do that. Okay, so our front cowl piece, we've got 3 heat sets on it that we need to do. So let's get that ready. There, there. Come back to line up the other one. You want to make sure these are flush, and if they do push up any filament, go ahead and trim it off so you've got a nice flush surface. Some of these you might need some tweezers to actually get them in the right spot. Latching piece, we'll get one right at the end. Hey, Shenanigans, how's it going, my friend? I'm not going to do these stupid bleeping standoffs because I actually have knurled standoffs that I will use instead. And we'll need to get our mid plate part and start working on this because there's a bunch of heat sets that go in here. So we freeze. Welcome on in, Shenanigans. Doing good. It's been a week. So Mrs. Dragon is still up in Virginia, and I guess my brother's mother-in-law came home from the hospital yesterday and went back to the hospital today. Apparently had a nosebleed that just would not quit. And as somebody who just had a stent put in her heart, I believe that's probably not a good thing. So haven't heard back as to what may be going on. So the rest of the week's still up in the air. And then toss in there that we've been doing performance review stuff and things like that all week. It's great. On the front face, two on the bottom. I'll try not to burn the heck out of myself again. Once again, these need to be straight up and down. So if you need to, double check with a tool to make sure that they are nice and straight up and down. Three in the back, one there, and it wants us to put a F2x6 flathead screw. And the one thing that does not seem to be in the kit, so we'll grab one. I know I've got one. 2x6 kind. This is going to be one of those little 1.5, and this is going to be, that's not even 1.5, that's even smaller. And we're going to be threading into plastic, so you got to be very careful. You don't thread out the head on this screw. Trying to get it started or tightened. I have to break out the iFixit kit to get this started. Break out the iFixit where I can get a good handle on that. Okay, and be used to adjust meshing of the BNG gears on the step, turning it all the way in at this step will make it easier to access. Okay. I'm going to thread it in so that it's flush with the printed part. That. And what's up? Like we're done with heat set inserts. We can move that out of the way so we don't burn ourselves any more than we have already. Yeah, we're trying to do the final little bits and pieces to get our Micron kit put together so that we're printing hopefully either tonight or at the very latest tomorrow. Let me pull this print off, speaking of which, so that we can get things going. And so for those of you that are interested, you may have seen this part the other day if you were on Chris's stream. So this is going to be the main X bracket for the tool changer on the black box. And this is being printed in Prilene polycarbonate carbon fiber. So yeah, it's kind of hard to capture the first or the that top layer here. Top layer is coming out very, very nice. These prints have been spot on. And doing these prints, I'm like getting ready, like I want to go and order like a case of this filament. Been amazing. Okay, so we did get a little kit that has all of our BMG stuff in it. We'll check this out to see if it is the real deal or not. And let me grab a paper towel so I don't lose things when I dump this out. So got a gear with the gear portion already on there and locked down, and I'm not seeing a flat. Have to see about that. There's the idler one, spring, the knurled nut, of course the plastic piece. Got our two little, was it MZ8 easy bearings or whatever. A spare, may not be a spare. Yep. So spare grub screw. I don't know why it always has it. And then our needle bearings and the rod for our idler, which we're going to use right now. So once again, we've done these enough. We will get our syringe of EP2 or EP1 Mobilux grease ready to go. Lubricate the bearings. A lubrication film is required to ensure smooth operation and longevity. Yes. So what we'll do is we'll take our idler gear, the one that doesn't have a spot for the grub screw, put that on our finger and hold it. We're going to take our needle bearings and drop them down there and just stack them up one on top of the other. The next thing, take a little bit of EP2 grease in a syringe and squirt some in there. Be a little liberal about it. Deal. And then the next thing we're going to do, we're going to take our little M3 rod and put it right down in that grease. Start pushing it down, keeping your finger at the bottom. And what that's going to do is you'll see that first bearing start to pop out, just like that. So take your finger, use your fingernail to hold that bearing down in there. Push the rod through with the other one. It's okay if you see any of that grease come out, because what's happening is you just pushed all that grease through those bearings on the needle there. So you want to go ahead and push that the rest of the way through, making sure that you do not get any grease on the filament. If you get any on the big gear side like that, don't worry too much about it. You don't want it in your filament path teeth. Okay? We'll go ahead and just wipe away from the filament path. Okay? Now we're going to take our idler piece. We've already propped the printed support out of it. Okay? We're going to hold it like this, and you'll see that there's a cutout, and the larger gear cutout is on the side where my middle finger is, not where my thumb is. We need to take our gear in that same orientation, lay it down in there, and then push it in until it snaps on both sides. Then verify that it rolls. So there you've got your idler bearing laid in there. Go ahead and wipe the tip for a syringe off, cap on, that'll go back away. That away a little bit later. We do need to add a screw here. We're going to add a M3x10 self-tapping screw. And that is just basically providing a little bit of added strength to the part. And that's going to go in this hole right here. 3x10 will go in there. And I really, really hate these little M3x10 like Phillips heads. Much prefer the M3x10, the socket head. Got an actual hex key head to it. So we got that done in there now. Check the orientation. Once again, big gear on the big side that like it won't go the other way. And then make sure that it moves and that nothing's rubbing. Then it says to check our gear and make sure that it's 3 millimeters from the face, the outer edge of the gear to the end. So you don't want to depth gauge this because your depth gauge will be against the recessed face. You want to measure from the actual lip that's on your gear. So you'll measure that lip, and as long as it's 3 millimeters or less, which probably about like 2.8, so we're good. We should be good. Check the fit of the bearings on the shaft. Yep, those are good. Okay, and then this is our motor piece. So we want to push the bearing in one side, and then we'll have a M3 hex nut that we need to super glue. So you don't want super glue on your bearing because then it prevents the bearing from doing its job, which is, well, turning. So I'm going to actually super glue it first, and then we'll put in the bearing right before we go to actually need to use it. Now give that super glue a chance to dry. You also want to be careful not to get threads on, or the super glue on the threads, because, well, that makes it a little bit harder to put threads in. So a little super glue. Put our nut down in there. We'll just let that set. If you want to use activator, you can use some activator. Or you can just give it a couple of seconds. This is gap filling medium. So I think it takes like, I don't know, 5 to 10 seconds to hold parts tight. 5 to 10 seconds to initially set, 2 hours for full strength. So yeah. Pulling it in there, counting a few. Should be good. Coming out. So we'll take the bearing and press it into this particular spot. It may take a bit. Try and use a flat surface. Push it down on there. You want to make sure it's fully down in there. It will be proud of the printed piece just a tiny bit. You want that, because that's going to hold, that's going to give the gap in your large printed or your large plastic gear. We're going to take its counterpart and put it right down here in this middle hole. Kind of becomes a pain in the butt. And then what I wind up doing is using the edge of one of these as a straight edge to try and press down across both faces. Get that lined up and in there. And if it's not going in, might have to, I don't know if it's filing or just a little bit of a scraping around that bearing hole. You might just have a piece of print, or in this case, I've got a sparkly fluorescent filament. So I may have a little piece of sparkle right at the edge that it's catching on. The other thing you can do is use your reamer, but the reamer has a whatchamacallit, a chamfered leading edge. So it might get a little bit of a chamfered edge there that'll make getting the bearings started easier. So yep, I think that'll be our best bet. So 8mm reamer, and I'm just going to do this by hand. Like I said, we're not going to be able to get fully down into the part because there is a bit of a chamfered edge on here, but it'll let us get the top portion done, which will let us get the bearing started in the hole, and will then make it pop down in there. And we can use the back side of this because it will be a flat surface to push down in there and get it started. And once again, it's going to sit ever so slightly proud of the printed part, but you want to make sure that it's flat across the surface. So it's parallel with the surface, and it'll be perpendicular to the shaft. Now we're going to start off by taking our shuttle, and it has a ridge piece on it, and that's going to be facing outwards. That shuttle is going to sit down in here. We're just going to push it back into the gap. So now we'll take our idler piece and set it in here. And then we'll take the latch and be cognizant of the orientation. So this is the way that we're seeing it from top to bottom. And that's going to sit right across the top like that's your whole latching mechanism right. We're going to keep this in place, and we're going to take our mid body, and it's going to sit right down on top of that. Might be easier. Oh, there we go. Handle that I had my hand. So it's down there, and it's got we'll say cutouts that go on. So you've got printed cutouts in the part that will go on these upraised printout or printed pieces. And depending on if you had any elephant's foot, you might need to clean up those inside edges just a bit, make the parts align easier. The other thing that it hasn't told us to do yet that would be wise to do, in the, I think this might actually tell you if preparations must be in the LDO version of that, is while you've got these parts like this and you don't have, take that out. Yep, we can put this back in actually because nothing comes through there. While you have these parts available, it would be good to take a 2 millimeter drill and go through this mid part to make sure that that hole that your filament's going through is perfectly clean. So if you've got a 2 millimeter reamer, that would be the best. I think that's 3 millimeter reamers. Have a 2 millimeter drill bit. You just want to make sure that it's nice and a clean hole all the way through. So pretty good. And it's really like that portion of the path right there. You're trying to make sure is a nice clean hole with no issues. Because that's where the filament would snag, is right there in that portion where it's trying to get around the gear. So it's coming out of either side or going into either. So using a 2 millimeter drill, cleaning that up by hand is a good idea to do now and saves you potential troubleshooting later on. After I like popped the part off and got it all ready to go and then didn't hit go. All right. So what is up next? We put our mid body back on here. Make sure that things are lining up and dropping down into the part. I am having issues with it lining up. Just know that if you have to do any massaging of your parts to get them to lay flat together, now is the best time to do that, because if you don't, again, problems come back to roost later on. And also, because these are top layers, it may just be that the top layer has a bulge on it and isn't completely flat. So just use your file and hit the top of it to make sure that it's smooth. And that may be all you need to actually solve whatever issue you're having. But always keep a small file here when you're doing these builds. It's perfectly okay to touch up these, the edges of these parts so that things clip together right nicely and you get nice good seams now. And it's obviously a tight fit, which is how I want to keep it as well. So we'll put our plunger back in, our idler, the latching lever, take our mid body, put that back in, making sure everything's lining up, getting that nice tight fit. And now we're going to put 3 M3 by 25 button head screws in. How's it going, Timor? Hope you're doing well. And where we go? Put the top, one at the bottom. So the top 2 screws, one is a pivot point. Top right one here is a pivot point for your latching mechanism. So this is actually going, not sure how I can show it, through that printed part right there. So that's making the pivot joint. The other side is going to be the latching point that latching part, like, I'll say, bends around at the top. And then the bottom one is truly just compressing the 2 parts together and holding them together. And being the pivot pin for this piece. So shake it around, make sure it gets lined up. Come on, you can do it. So all of these you want to just snug up, and then as soon as you're going lightly, and then you feel it, the tension change, stop. Because once again, this is a pivot arm. If you make it too tight, it's not going to pivot. This is the latch arm. So this screw, pivot point for this, the lower screw, pivot point for your idler. Top screw is the latch that this hook goes over. And that is what is going to provide the tension to hold the whole thing together and provide the tension on it. So you want to make sure that you're screwed in tight enough that it's holding all the parts together, but that you're not binding or seizing those parts. Okay, that's going good. Now we're going to have two screws that come up from the bottom, and these are going to be M3 by 10. Got 8s and 12s and button heads in this kit, so we'll reach over here and grab an 8 M3 by 10s out of my kit. These are once again button head cap screws. So I will tell you this, Timur, my Trident 350 kit comes with a 6-cart ERCFA for the ERCFA 1 or 1.1 or whatever it is. And I ordered, because we haven't started that build yet, I ordered a 6-cart to 8-cart upgrade kit from, I think it's like Sealead and Formbot off of AliExpress. So yes, I have one kit, but I ordered 2 upgrade kits. I want to see what they look like and possibly compare and contrast the quality. And if I need to, I'll take the best parts out of each one. So we'll see. That's all nice and tight now. Everything is got good seams on it. Once again, we'll check functionality, make sure that everything is moving as it should. So we're good there. Next up, it talks about getting our gear ready. So this gear looks like it's set on there appropriately, or no, wrong direction. So we need to open this up and pop the gear off. And flip this around, which is also a good time to put some Loctite on the grub screw. You definitely do not want this grub screw coming out. So we get our grub started again. What I tend to do is get it on the shaft and just give it a little lock. I'm going to set the distance here in a minute. So I'm just snugging it so it doesn't slide all over the place and doesn't rotate on. So that's our orientation. And we're going to slide this in from the back side, which is why we need to make sure that that bearing is down in there, is nice and straight, so we can slide this in. Like that. Do a little bit of a turn, and we should be able to line up the gears underneath. Then it tells us to put the back motor on. Now what I'm going to do first, because it's easier to see some things right now, is kind of see where I'm at in relation to, that's going to be hard, in relation to our filament path. And I am seeing that we are way off the filament path. We may have to bring that down some more. In there, and do that, push it down. A lot better alignment with the filament path. Close things back up to make sure that we're nice and tight when we do this. Now it wants us to put our back plate on, and when we put our back plate on, that bearing needs to line up on that shaft. And once more, we're going to have some registration printed areas, so we need to make sure that everything lines up and goes flat when we align this up and put it on the shaft. Just like that, we're on the shaft. We've got our printed part put in there. We're going to add 3 screws. 2 of them are M3 by 6 and 1 M3 by 10. We know the M3 by 10 is not in the kit, so we'll grab one for mine. All right, enjoy dinner, Hybrid Robotics. So M3 by 6 is the top, the left side, and then the right side will be an M3 by 10 button head. So we'll just put these in there, get them snug. And then once I have all 3 kind of in there and snug, I'll go and tighten them down. So down, snug down. Snug down. We're getting good movement with our piece there. Now we want to look in from the bottom. That's what it's showing us there, is looking in from the bottom and making sure that we've got a gap and that our gear isn't rubbing. It seems to be good. No touching. Then we're going to work on doing our alignment. So we're going to open our latch, right? And we need some filaments. So have some filament, sure. I mean, it's polycarbonate carbon fiber filament, but it's filament. It'll work. We'll give it a nice tip. And all we're going to do is just, try and straighten this out a little bit. And slide this down in here and try and align our gears. So we put that in there. We can use a thing to pick this and pull it down. And what we're looking for is that our filament is lining up. Kind of hard to see there in the groove, which it is. Is moving the big gear nicely. Possibly see the big gear moving. So I'm going to latch this in place. Getting good movement. Apply some tension. And I'm getting good movement, so I'm not getting any like backlash and no I'll say catching or grinding of the gears. We've got our latch piece in here. I'm going to submit it right through there. And get that screwed in, maybe. Line up on hole, screw into, there we go. Now, when you clockwise increases, counterclockwise reduces, and on the left is what we're looking at. So with the tension knob in there, if it's correct, your tension knob is going to be vertical. If it's downward at an angle, your shuttle's not locked in place. So we should be able to unlatch this, pull this open, zero tension on our piece of filament. We're going to push this over and it will drop our latch down. We'll make sure it's fully latched. And now we've got tension on our filament. Right? Still moves. You'll be able to rotate this by hand and get it to move, which it is. Probably a little hard for you guys to see. But rotating our wheel, our gear does rotate and move the filament. So our alignment's good. We want light teeth marks. We have our anti-squish thingamajig. I can't check teeth marks on this because this is carbon fiber, polycarbonate. I don't want to keep trying to run this through here. It will damage these non-hardened gears. Loctite to the side. We're going to use our fans. These are our little brushless, like 3010 squealers. And you want to make sure that your exit point's always down and that your fan is facing the opening. So fan facing the side opening, exit point facing down, and it should slide right in with no issues. Should slide right in, no issue. Except I'm touching on the lip or just not getting it straight. Doo-doo-doo. Tracing down, yeah. Think- yeah, housing started splitting. That was weird. There we go. And one inserted. The other side, once again, fan on the outside, blower facing down. But this time you want to make sure of where your wires are routing. And actually, I think we got to do the center fan first, right? Center fan first. So we'll grab our, that's the controller fan. Where's the other fan? Hey, blower fan, or outdoor blower fan. The key. Maybe that is their designated. It says controller fan on it, but I'm wondering if this is a 5-volt. I guess if this is 24-volt, it's probably not for the controller, but is for the hot. That's 24-volt, so yep, this would be the one. So you want the fan coming out the side, going up and through the trough. So fan coming out the side, label facing the back because that means airflow is coming from the side without the label towards the label. We're going to put the top edge down and then push it forward and down to clip it in that little lip. And then once again, your fan line is going to route down in the gap like that. Hey, Ram Online, welcome on in. Hey, Aaron F. Geard, are you still out there? We're going to take our other fan once again. This side faces outside, the blower faces down. We're going to route our fan wire in the same kind of manner through that trough, right? And out. So we need to make sure that we get lined up in that trough area and push our fan in, making sure we don't touch the things. Make sure it's snapped in there and properly flushed in the housing. And now what'll happen is we're going to have a mount that the hot end goes on, and that mount's going to slide right in here. And then it's just going to be held in place, friction fit. So that mount for the hot end is actually printing right now. So at this point, yeah, we can go ahead and install the pancake stepper. This is our moon stepping motor. So this is a moon's version of the motor. One thing that you'll want to do is just count your teeth. Sometimes you can tell by the number, like the model number. This is a 14, so a NEMA 14 HRA 1L410. I believe that means it's a 10 tooth, but you always want to count, and that is a 10 tooth spur gear on there. And that's going to be critical because you can select between a 10 tooth or an 8 tooth, and it will give you a completely different rotation distance. Now, what I'm going to do is I'm going to cheat real fast and look right down here at the tool head that we did on the salad fork and just see which way I brought the wire out. So I do want the wire coming out from the top, meaning don't mount the motor like this because we have the sensor and a mounting screw and stuff. We want to mount the motor in this orientation with the wire coming up. So we're going to use an M3x10 on the left side. Of course, the one screw type that we don't have in there. And I'm trying to dig through here and find standard silver colored screws so that they match everything else in the kit. So the left side is, I'll say, our static or our pivot side. We come in from the front into the motor because the motor is going to be, the little wings on the motor are threaded. I have to open this up to be able to get to our motor screws. In left side, static point, right side will be a pivot point. So we'll get that in there. And what we're going to be looking for is a little bit of tension. So the left side's in there, the right side we're going to bring down, and we're looking for a little bit of tension. So the screw hole on the right is a slotted, allows you to provide a little bit of gear mesh adjustment, also called backlash. If you have your gears too tightly bound, then you will get, well, if you get them too aligned, you can induce binding into the motor itself. So you want to bring it down and mesh the spur gear, but have a little bit of backlash, meaning you can just start to move it in the opposite direction and you can feel a little bit of play. If you don't have any play and you push this all the way down, you're going to have a lot of issue and you're going to have to use a lot more torque to get it going, is really what it boils down to. So kind of get it in the right spot. Open that up so that you have access to the screw hole and get your other screw started. And once again, before you give it the Ugga Dugga for all it's worth, take the time, latch it back up, move it with your finger. Make sure it still moves freely, but that everything is meshing. You're not feeling it snag or fight. Then just lock this down, and that'll be your position. Yes. And then this is where I'm printing out the dragon mount right now. We'll install our dragon mount, and we'll run our wires up as appropriately. And then we'll be able to start getting this ready to go on the physical tool head or on the printer. So while we're waiting for the part that we're going to need to print, let's come back over here and finish getting our boop ready. So we need to start fastening our boop pieces together and getting our overall mount ready on the printer. You get this out of the way. 2.0, 1.5. This back over here. I'm sorry, people, I need to get some coffee. Okay. Sorry about that. Now we'll switch over to our other other application. Not sure how this shows up. Not bad. And what I'm looking at or what I'm looking for is just the assembly piece. So this front piece is two pieces. You've got the actual mount piece. This is going to mount on our vertical rail. In fact, let me go ahead and bring this back up here. So we've got our X carriage here, a lot of extra belt length. We'll still need to tighten this up a little bit because, like I said, I think I need to bring this in a little because I'm rubbing on the belt. So this center bar, the gap needs to close some. Which will, by definition, also require us to, well, we haven't tightened the belts yet. We just had the belts in place. But I did notice this when I was putting the gantry in that the belts were catching in the corner. So I'm just going to go in here and loosen these screws and push the say the two AB motor mounts towards each other. Take up the slack on between the motor mount and the rear extrusion. And I should possibly be able to just move this back. And that should help us bring these ends together. Apparently my belts are a little bit looser than I thought they were. This will be part of the normal rack, deracking and tweaking part of the build anyhow. So but on our front piece here, so we've got our belts installed. They're somewhat loose at the moment, so I will work on really needing to loosen this up a lot more. It's funny how it feels like one or two teeth make a huge difference in how loose your belts are. I remember when we installed this, we didn't even put all 4 screws in. We were just kind of doing placeholders to get our belts run, not necessarily fully tight. Looks like we're doing good there now. So what we need to do is we need to install our linear rail. And when you install your linear rail, you cannot have the carriage on here because there's not enough room to move it up and down and get to all 3 carriage pieces. So what we need to look at here, and I'm going to spin this around to the back, right? So our top screw, which is going to go into a hex nut that we have back there. If I double click that, it tells me down here at the bottom, it's an M3x6 socket head cap screw. So let me see if I've got those in here. It might not because this kit's not necessarily designed for boop. So I may have to improvise. And I have M3x8, but not M3x6. That does say M3x6. So I may have to use an M3x6 button head screw instead of a socket head screw. And we do not want this linear rail coming out. That is in a printed part. So this top one is going to go in without doing any Loctite. We should be good without having to put any Loctite on here. But I'm also not going to tighten that up really bad. I'm just getting it in there so there's a little bit of wiggle room. I want to get all 3 aligned first, then put it in. The next one is going to go into a heat set insert. And that looks like an M3x12 socket head cap screw. Looks like I don't have M3x12s in there either. So We'll grab an M312 socket head cap screw from over here. And we're not going to tighten it. And then, whoops, the bottom one here is an M3x16 socket head cap screw. And this one is going to get a M3x4 underneath the head. So we'll take an M3x4 heat set insert and just screw it down up against the head of the bolt, or the bolt in this case, because we're going to screw it into something. And that's going to act like a spacer that kicks that bolt head out. So when I go to tighten this down, you'll see that this M3x16 screw head is going to stick out. And that becomes my lower end stop basically for this rail. What does that say? Button head at the top. And I want to put a couple of more M3x6 button heads to finish tightening down our X carriage. Get these put in. So how's it going, Stephen Poole? Hope you're doing well. Royal Nomi coming in with a drop. Yeah, there. I was going to say, is the drop game working? So we'll give this a little bit of ugga-dugga. Now, one thing that I failed to do earlier, hopefully I can still get it in here, otherwise I'll have to undo it, is you'll notice there is a pair of M3x40 button head cap screws that go down through here. This provides additional rigidity, so you need to put those in there. You cannot overlook adding those, or you will have some issues. So grab some of your M3x40s, and these should go all the way down in there. And once again, this is adding additional rigidity on either side of the linear rail. Just chilling. That's good. We need to do that in our lives sometime. I always tend to forget to put these in before I mount the X carriage. Partly because there's no manual. It's just the CAD, and I don't look at the CAD until I've already got the X carriage put on. So Aaron F. Geared, are you still out there, or did you have to take off? Are out there, please say something. Okay. So those two are now on there. Now comes a little bit of the fun enjoy. You put this stuff in here, this stuff out of the way. And by fun and joy, I'm talking about getting our carriage on there. This is a honey badger carriage. This was a honey badger kit. I will tell you that it appears that I am missing at least one ball, but we should still be perfectly good for the amount of travel that we're going to be using out of this carriage. Like we're talking, we're going to be moving like 6-7 millimeters at the most once we mount the rig. So we're not talking like anything major. We'll have plenty of stability in this part, but I am going to go ahead and lubricate this rail up a little bit because it is looking a little dry and peakish. So grab a glove. Ow. Oh. Just add a little bit of lubricant in here. Make sure that we squeeze it fairly well into the gap. And like I said, we don't need to massively and majorly load this up. So we don't need to do like 2, 3, 4 passes at getting this in there because once again, we're talking 6 or 7 millimeters of travel. It's not like it's going to be going continuously through its bearing race in the back. So make sure that it's moved around. So get the 2 balls that started to run out on their own. You are not allowed out after butt back in there. Okay. So now's the fun part. We have to manually put this on. Now, if you have if you've got a rail guide, you may be able to put your rail guide on here now and then feed it on there using the rail guide, and that will be easy. If not, then you will want to use your finger, kind of like I'm going to do right here. Use your finger in the gap to push the little spring levers on each side, because what happens is as you're putting tension down, the springs will gap out in the middle, and that's what allows the balls to escape. So I put my finger in, kind of give a rotation to hold those little springs in the gap as I start to slide this on. And I'll move my finger ahead of this little slide bar. And if everything goes right, which it didn't, the balls stay where they're supposed to be, which is in the channel. Don't keep popping out. now, and I don't know why this particular rail or this particular carriage, the balls are jumping out on one. I don't know if it's the fact that they're all missing and I've lost the ball somewhere or what. I've tried checking, and apparently I don't have the right size bearings for this particular carriage, which I believe is a 9H. Yeah, 9H. I think I have balls for 7 and MGN 12, not 9. Oh, hey, Pezliz, how's it going? I hope you're doing well. You're you're doing well. Um, I'm dealing with linear rail balls that just do not want to play nicely. I'm going to just try and see if I can't get this installed directly on without you. There you go. Apparently, it didn't want to. It didn't like the rail guide, and it just wanted to go straight on the rail itself. I get for trying to do the rail guide thing, and I normally just put them on the rail by hand and don't have a problem. But we've got our The base of our boop carriage installed. We've got the linear rail for boop installed now, which, by the way, is the same exact linear rail as you would use for tap. That linear rail just came off of a tap, so not a problem. Next up, what we got? We got this, that. We'll have our two pieces here that need to get connected and then installed. So we need these two screws on either side. And these are M3 by 16 socket head. I think I'm going to have to grab my own. So we'll go ahead and get these in there and started. And when I did these holes, there's a whole lot of plastic thread there. So I need to actually run the screws through these holes from the insertion side and get rid of that excess plastic so that we don't foul these threads. Lots of tools to take back with you. Well, that's good. Yes, she made it here in time for the lube. Of course, Pezlas would make it here in time for lube time. Anybody know if the Big Tree Tech filament sensor is a direct replacement for the Creality filament runout sensor? I do not know. The only printer I had that had the Creality filament runout sensor on it was a well, no, I take that back. The Ender 5 had one, and then the Ender 3 Max had one, and the Ender 3 Max is with a new family now. I guess that's the that one pushed out a nice plug. The other one, not so much, which makes me feel like this one may have a not bad angle on it. But so we'll be coming from the front here at an angle, and the rear piece will go in that basically make L. So this is how we'll be screwing in right through that angle there. Lined up. But yeah, I know how cool it is to get some of the older tools from the family. My dad um, knows that me and my wife do some woodworking projects. So he gave me some hand planers from his dad. So I've got my grandfather's wooden hand planers. So that's kind of cool. That's kind of cool. Okay, so both of those screws are up and into those heat set inserts. Once again, these two will be the front mounting for the tool head. This top one will be rear mounted from the back into the tool head. These two holes will mount the filament runout sensor. And there will be some interesting things. We can't mount that just yet because if I mount it in this orientation, right, where it's angled down, so I still have access to that, then I can't get this on and off of the rear, and it's going to hit the extrusion on the back, right? So this sits here. This can't go in the downward position. So it has to go up like this. Well, in going up, it covers up this hole. So what we have to do is mount our tool head, get the two screws from the front, the one in the back. Then we mount our sensor in here from behind with two screws. So I learned that on the salad fork, and it's just the way that Boop is laid out. Now, if you have a sensor, there are some of the, like you can get the bare optical sensors and then do your own connections and adding, you got to add, oh, screws and stuff. Yeah, or not screws, but fat diodes and stuff like that to do polarity protection. So this is going to get mounted with M3x6 button head cap screws again. So 3 left in the kit. Grab a 4th one out of mine. Once again, this kit was made for a standard carriage and not the Boop tool head, which adds a bunch of fasteners. So can't yell at them for not having the right amount of fasteners. Well, you guys were letting me do that, weren't you? Thank you for the follow, little Diabeto. I can't mount this just yet because there's one other thing that I forgot. A couple of other things, actually. So one is I need I believe M3x6 countersunk screws here or magnets. And then I also need the magnets that go in either side here, which would be the magnets that fit in these slots. So I need to get these magnets put in, and I need to make sure that polarity wise they will um, attract to either the screw head, or if I decide to go double magnets, which I've never done double magnets, especially not on boop. I've always done the screws, but depends on the strength of your magnets as well, and on your print tolerances. These are either going to be easy to push in or not easy to push in. So what I will do is grab one of my Nipix pliers that KB3D Chris was nice enough to send to me. Diabito. Okay. So we'll just put that on one end. We will line it up in the spot on our printed part, and realize that I had it too far open. Oh, there we go. Just press it down in there. Once again, these are the nice Nipix with the smooth faces. And you're going, well, you're putting a hex-based magnet in a hexagonal hole. Like, how does that fit? Well, it fits rather well because there's a relief cut on one side that basically allows it to push out and self-center in there very nice. So we just get it lined up, slight squeeze, pushes it down in there. We've got our heat set inserts already in there. So these should be good to go, and they are going to be opposing each other, right? Because I put them in the same orientation, because they're going to be on opposite sides. And which side goes on what? There's a 1 and a 2. Can't remember which side goes on which. Anybody remember? Okay, I think it's 1 on the right, 2 on the left. Does that make sense? Because your heat set insert is to the inside, so towards the center, and your piece should just slide right in there. Looks like it might be the wrong direction. Over and try that way. Yes, that looks right. So the 1 marking, and so when I say 1 or 2, there's a little divot right there on the side. The 1 will be on the left, 2 on the right, and you want it in such a way that the heat set insert, once again, is towards the inside, and it should just slide right down into the slot, just like that, and it'll be at a little bit of a slope from the bottom to the, yeah, it's angled from the bottom further out to the top further in. That makes sense. Because that will line up with these that are kind of angled down and in. So now, when you do this, Aaron, do you do the double magnet, or do you do the um, screws on the one side? You only do 2 N5 Tues. Yeah, I've always done the 1 magnet on these and then the screws on this side. I've never seen, if it helps. I know that the tap, like the CNC tap, has magnets on both sides. I've just never set it up that way. I don't know if it's good or not. Well, that's true. If you've got magnets on both ends, then it's going to be a larger force to um uh the break, which means it's going to hit the bed with a larger force. So let's go ahead. I'm going to need, what is it we got? In countersunk screws that we want to put there. Is it M3x6 countersunk? Do I have M3x6? Oh, might be threes here. Check. Nope, M2.5. That's the screws in here. This was all the fasteners that came off tap when I pulled it out. So let me see if I've got. Yep, did get it. Oh, one countersunk, two counter. Oh yeah, I didn't even think about that. You went to different sides of Canada, didn't you? So there is an angle to this, and you need to kind of, once again, work that angle, and you're screwing into plastic. So just be cognizant of that as well, and don't overturn it and strip it out. You want this part to be pretty much flat with the printed part. Okay. And then we're going to need M3x10s with um, washers on them to hold the magnets in place. Just going to grab those out of here. So the magnets, those little magnet trays are, the screw holes are slots. So what this winds up doing is, even get this to on. We're going to screw these in and make sure that they're tightened up as they're fully pushed back. We'll mount the frame, and then we'll release the magnets, allowing them to pull themselves forward and into position. And then we'll lock them down. one, maybe it wasn't. Those are in place. Now this will go on top because we've got our screws in place. This will help align it as we sit it on there with the magnets. Get our 4 screws started here for mounting it on the rail. Hey, Daddy Wazzy, how's it going? From the traffic. Uh-oh, you on your way home, bud? Just one time zone northeast, so you're up a little north and east of Maine. Okay. Yeah, I thought were you on the Z and Z show last night? I'm gonna tighten this down. Okay, so we've got that there. We've got, our little bit of travel movement there. Now what we're going to do is we're going to release the screw some on the magnets, allowing the magnets to slide forward. And then we'll lock them in place. You feel them slide forward and give it a little, whatchamacallit, click. Or what's going on with this thing here. That magnet didn't look like it forward. There it is. Just hung up a little bit. It slid forward and clicked. So it's basically self-aligning magnet. Then you'll screw them back down. And that locks them in place. And that sets your brake force tension on your tap. So let me what? Hear that. I can't help how gorgeous these top surface. A little bit of ringing. This is the bottom. The PDRG. So this is polycarbonate carbon fiber filament from Prylene. Love it. Been sitting here printing all the parts for the black box using this filament, and it is making me so happy. I'm in section 4 now of the manual for printing out the parts there, and just waiting on the kit to arrive. I do have some parts for like tool heads that I can start working on, but you know, I want to hold off. So what we're going to do now, let's ream some holes. Always a good time to do that, just to make sure that our holes are good to go. I'm going to do these through holes here, which are the mounting holes. Those are good. And then top to bottom ones, let me double check that these are M3s and not like M2.5, before I decide to go for M3. I think those are M2.5s. Well, I didn't do an M3. Okay. So, one thing to note on your mount, you've got a sharp edge and a slightly rounded edge. In other words, your we switch. Your tool head, the rear of your tool head is where the words are. This is going to slide in from the back of your tool head, and then the screws will mount through the front. That's a tight fit. I may have to do a little bit of sanding or filing, which, you know, mixing filament types between a ABS and a polycarbonate, they're going to have different shrink rates. So just going to lightly file each side. Going to go in like that. So now I need to pull that back out and actually put a tool head on it. And I'm going to look at the way my tool head goes. I can mount it like this, where all the wire comes out the back, or I can go to a side, but then I'm going to have issues with my this metal support. I can pull it up, but the other side of that is this is going to mount right there. So if I come straight out the back, then I'm going to be hitting the mount. So I need to be able to preferably kick this to the, you know, at an angle, or I'm going to have to come out the side and do a a bend on this strain relief bracket, preferably without breaking any wires in the process. Okay, once again, we're going to line this up. The other thing that I want to do is I'm going to bore this center hole out to a true 4 millimeters while I think about it, because if I don't, I may have issues pushing my PTFE tube in. And if your PTFE tube's too tight, it'll compress on the inside of it, and then it will cause you to get jams and clogs in your actual path between the extruder and the tool head, which could cause too much back pressure on the extruder itself. So definitely be aware of that. And we said these are M2 screws. So, or not M2, but M2.5. Did this thing have M6, 12, M2 5x6? There we go. M2 5x6 button head cap screws. Darth Gollum, how are you doing? Welcome on in. Thank you for the resubscribe, my friend. Thank you, thank you. We are working on a tool head installation. Apparently those are 1.5 instead of 2. Correct. And our tool head of choice is the one that came in the kit. And we are installing it using the Mini-Stealthburner. Tool head mount. And the main tool head was printed in red. And this part here, so it was printed in sparkle fluorescent red ABS. And this particular part here, because, well, I didn't have anything proper loaded up anywhere else, this is the Prilene polycarbonate carbon fiber mix that I'm using for my black box parts. Figured it was already loaded up, and all my other printers currently have PLA in them, so. And polycarbonate carbon fiber is going to be more than sufficient heat tolerance and strength-wise for this part, so there's no worries there. Blah, 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 blah. That's for the Revo. And we want 6 millimeters. So regardless of what hot end you choose, you want 6 millimeters above the mount here. So what we're going to do is we don't want to use a reverse Bowden tube, which is 3 millimeter inside, because that gives the ability for the filament to bend and squish within here, especially if you decide to ever print TPU on a printer like this. It'll give you issues. So what you want is a standard piece of PTFE tube with a 2mm inside diameter. So yeah, I really wish I would stay away from the Capricorn high tolerance on this. Unless you're printing a ton of TPU, I would go with just the 2mm or the standard 2mm inside diameter, because especially if you're going to be doing any type of like color swaps and stuff like that, because you will have tips and the tips of your filament will swell a little bit. And you definitely want to have the ability to account for, that's interesting. Sorry. You need the ability to account for that filament tip swell for getting good filament changes, whether you're doing it manually or with any type of automated mechanism, whether it's ERCFA or Million or what have you. So what I was doing was I was trying to push this in, and you saw me put my thumb there, pull it back out, and measure it, and I was only getting down to the top of the metal heat sink. I wasn't getting in there. What I did was I just backed off the 4 screws, and I just felt it drop in there. So if I put my thumb there now to measure it, pull it out, it's now evident that it went all the way down into the flat of the hot end. So just be aware of that when you're setting these up. Make sure it's fully down seated in there. And now, once again, we need to mark 6mm of length and then pull this out and cut it to length. So just going to kind of line the edge of my PTFE tube up here, find my 6mm mark, mark it, and then we'll cut our tube. We'll chamfer both ends, and then we will install it. And to try and ensure that I get I've used this for a while. A better way is using the tool that Steve Builds has that I'm probably going to print out and start using, because it fully surrounds the piece that you're cutting. Here, what I've found is I do like this, and you see there's a bit of a bend in the tube. If I'm not careful, I will cut this at a slight angle, and it's just always a fight to ensure that I don't cut it at that slight angle. So let me get this down in there. Yeah, that was a nice clean cut. So we're good to go. Once again, we'll take our, this is a deburring tool that I use for my aluminum airplane. And I'm just going to use this to chamfer the inside of both ends of this small short piece of Bowden tube. So what I'm trying to do is ensure that the filament, as I'm inserting it, has a nice clean path of getting out of the extruder and into the tool head itself. So we'll take some filament and run it through here to clean out any of the burr that got stuck. Want to make sure that there's no PTFE left in this tube, because if you get a little bit of PTFE, it will clog your nozzle. Just take your time. Make sure it's as clean as possible. And by the way, this is the Pyrene carbon fiber polycarbonate. So it will modify the inner edge of this just a tad bit, but that's all good. We'll take this and insert it back in there, making sure it goes all the way down, and I've got my 6 millimeters left and nothing more. Then I'll use that as a guide to go back ahead and tighten my hot end back in the part. And this is the hot end that came with the kit. You can upgrade to, a dragon, an actual dragon, Thetis dragon, or the like a dragonfly. So I believe when you order the kit, you can get either one of those. I went ahead and just figured out what the heck. This is a standard CHC heater element. The 2 set screws here allow you undo the set screws and you can pull the whole heat break out to replace it. So I'm not sure if it's got a hardened heat break in it or not. It is an E3D. I believe that's got I believe I put a steel nozzle in this. That is an E3D M6 nozzle. I'll verify. We'll double check and see if it came with a hardened nozzle or if I may have added one, or if it's just I'm smoking some good stuff. So you'll want to angle this down in there. You're trying to get the PTFE tube lined up in the hole, and then you'll slide this up into the channel. You start from the bottom and just bring it all the way up like this. Just mind your wires in the process. So I'm going to have to undo that and twist that around and get myself an angle. So we don't want it coming out straight to the back because then we'll interfere with the mount. We do want it to come out at the side a little bit. I'm going to bring it over to this side because there's less, well, no, it needs to come over to that side, the way everything mounts. Put that up into position. whatever reason, it doesn't feel like it is. Oh, there we go. There we go. Yep. So there's our tool head. Everything is lined up. We'll be able to bring our wires right up this way on one side. One wire will come up the other side just fine. And we'll have our tool head mounted right back here. So let me get my heat sock back on. Okay. I forgot they had their cutting tool here. I probably have that laying around somewhere, and probably would be a good idea to keep that for the 6mm cut length. This will mount using a M3 by 35 button heads. Well, it's calling for button heads, and the only M335s I have are socket heads, which should fit in there fine still. So we'll use M3 by 35 socket heads. Before we do that, let me put a couple of zip ties on this. What are we doing on time? 9 o'clock. So we've got a couple of zip tie spots here, one on each side. And we're just going to use that to zip tie our wires up on the side. And we're going to hope and we're going to pray that this extra bit of sheathing here doesn't cause us any issues with fitment on the carriage. If it does, we're going to have to try and figure out how to get rid of that without causing an issue. Yeah. We'll get that tight. Shorter wire. So you've got two long wires. The two long wires, the longish wires, should be our external fans, and then the part cooling fan will be the smaller wire, smaller length wire, because it's having to come out up the channel this way and then out this way before it exposes. So this will be our hot end cooling wire. And normally I'll try and route like my heater wire up one side and my thermistor wire up the other side, but they're combined here, so I really have no choice. It's just trying to keep them out of the way so it doesn't interfere with the actual mounting of the hot end, which right now it doesn't. So at least I don't think it does. Let me run a couple of screws and we'll see. So there is a locating notch that the motor plate will locate into. There's a little notch there. That gives you a good idea of whether or not you're in the right spot so that these holes will line up. These are tightening into heat set inserts um, in that mount that we have on the vertical linear rail. And there's your boot movement right there. And there will be one screw that comes in from the back. And that's why, once again, we didn't mount our sensor yet, because with reusing the sensor, when we go to mount it, this sensor, like I said, we can't mount it with the PCB heading down because it fouls against the extrusion. So the PCB has to go up. And when we mount that, that now is covering up that screw hole. So I'm going to bring you guys in here for a closer look at that. So when this gets mounted up here, we lose access to that, well, easy access to that screw hole. For maintenance, we can probably get in there later on once we have the M3x8 screw, I think, that goes in there. But right now, I would get that screw in there first, then mount your sensor board, and then we can start building out the rest of the tool head. So that is a okay, that says M3x16. That is not an M3x16. According to Boo, that is an M3x8. It would be an M3x16 if it was the standard mount, but the standard carriage mount is a lot different than the boot mount. So this is an M3x8 button head. For some reason, I never seem to be able to get this to line up appropriately in the hole to capture. Maybe it did. Nope, it did not. Ooh, is there foul plastic in there that I didn't clean out? Nope, just a straight up alignment issue. Hmm. What it seems like is there's a misalignment in the hole here between my boot and this printed plate. You don't think I'm going to get that figured out here. So for now, we're just going to go 2 from the front. I'll have to figure the other part out a little bit later. The sensor would mount with M3x8 screws would mount the sensor here. So we'll go ahead and do that. These are going to tap directly into plastic. So we'll go ahead and get that on there, and I'll worry about that other sensor in a little bit, or the other screw in a little bit. Now, one of the things that we'll need to do is verify the pinouts as we start installing things on the board, being our toolhead board. So we'll have to be cognizant of that as we start working through the next pieces. There's that. Now we're going to need to that's full back. I'm going to try and do is see about getting our bed lined up and squared. Looks like full back. Like full front there, so see if I'm straight. Straight-ish. Okay. Looks like the bed's down in the right spot. Darth, hope you're doing well. Hey, Maker Viking, how are you doing, my friend? Welcome on in. We've been working on the Micron and just sort of tidying some things up. We've got our tool heads now mounted. We of course need to do some wiring up. We've got our bed mounted and wires shoved up underneath the printer. This is our Y-end stop. We'll still need to add our cable chain and do that piece. We'll need to route our umbilical, of course, once we get our tool head board installed. It's right here. You got some awesome news today, Darth. What is that? Now, once again, your kit comes with pinouts and everything to pin out and do your plugs. It comes with standoffs. I've got different sets of standoffs. These are M3 by 20 anodized aluminum knurled standoffs. That's what I'll be using on this build. And what we're going to do is we're just going to screw those on the back of those M3 by 10s that we had come in from the front. And the other thing I noticed is I did not print out a plastic backing piece for this. So that is something else I'm going to need to do before I can mount this. But as you can see, our motor mount, our thermistor, our wire, all of our wires should be pre-crimped to the right connector to plug things in, minus our this sensor. We may have to depin it and repin it. I'll have to double check which connector it goes into. And when I go to do this, I'll probably just set the salad fork up on one side, this on the next, right next to it, and do that piece. But we're going to hold off on this for right now. Don't hold us in suspense, Darth Gollum. What was the good news you got? Naked Viking finally back home, probably not for long. Trying to get some work in on your projects. That's always a good thing. So I think what I want to do now, before we get going too much further, of course, we'll have to work on our Y-end stop and all of that goodness, our X-end stop, which I did not install yet, so I will have to install that, get that run up to the tool head. Probably one of those things I could have installed before we had the tool head mounted. I can still take the tool head off. Oh, not only did your engineering club win State of Minnesota Real World Design Challenge again, 8th straight, 9th, wow. But the second place team from your school earned one of the 4 wild card invites. They'll have 2 teams competing in the national competition in April. That's awesome, dude. That is freaking awesome. Man. Okay, so I want to get some other stuff on this printer. So I'm going to take her and flip her over, make her shake and rattle with all of the loose nuts still running around there. We've got our wires coming out of our bed. Flip those over there out of the way for now. We have our Big Tree Tech Manta M8P. So A and B, or B and A, and our 4Z motors. We don't need an extruder motor because we're using CAN bus and it's going to come off the tool head. So we'll take and mount this. And the way I've got it is I want to mount it this way. I may have to mount it the other way because it offsets it this way, and I won't have room to put um, the power supply. So I may have to actually run it this way. Now I'm going to be like right up against the back side of the motor with the rear of a PCB. Well, that stinks. Because now what I got to do is I'm going to take the mounts off. At least this one will be easy. I don't need to undo the, or do I? I don't know. We'll see in a second. Yeah, I will. So what I have to do is swap the ding clips around so that so I need to physically take the ding clips and turn them on the mount, which in this case should be mounted opposite. This one does look centered. This is the one that concerns me because this is an offset mounting bracket. So I think I really do need to flip this one around to give me the best clearance option. Because I don't necessarily like this board being right up against the back edge of a motor. And for those of you playing along at home, when we were looking at the manual, it was showing this whole like weird convoluted flipped up thing, but it was using a different mount styles because of it being the 120, the manual for the 120 part. With the 180 parts, they're different. And yeah, they're just different. I'm not sure if this will change the alignment too much or not. But it might give me an option of sliding the DIN rail as a whole a little bit differently. But this has that offset mount for this one side, so I definitely had to put this mount on at least one side. Daddy Wazzy, thank you for the follow. You were not following? I thought you were following already. Did Twitch do one of its things and auto unfollow you again? Yeah, those kids did some amazing work. That is pretty awesome, Dark Golem. It's amazing what kids can do given, guidance in a task. Okay, and the other thing I need to do is this is the front. So this will be 0, 1, 2, 3 as far as Z motors go. And I don't know if they've actually labeled the Z motor wires specifically. Let's dig through here and check. No, these are Z motor wires. I must hit unfollow on the phone. Oh, well, that happens too. That happens too. Yes, these just say Z motor to Z motor. So what I'm going to do is I'm going to install the Z motor wires to the Z motors. Because what I need to do is try and figure out like lengths. Because that will determine most likely which orientation I put the board in. Okay, and that's so my desire is to put it with all of my DC connections to one side and the AC connections to another. So if I put DC here, then my power supply would go on there with the DC end on the far side, or return this way. So this would be all DC. So if I mount it like this with the DC side over here towards me, then my power supply will be mounted the same way. So my two DC lugs will be faced towards me. And what that will mean will be all of my 100 volt or mains voltage wiring will be on this side. So my SSR, my bed, and stuff like that will go over here somewhere. So now it's just more a what's my spacing going to look like for my board. Can't even get that to latch in right. Still have spacing there. If I turn it around, won't have spacing that way. Doesn't matter if I flip these around, they're going to be in the same boat. So what that tells me I need to possibly do is loosen up my DIN rail screws some. So I can possibly slide my DIN rail up. At least enough that I can get the board installed. And then I can slide it back and give it just enough of just enough clearance. Don't need a ton of clearance, just a little bit clearance. Where we need it, but I need to undo, I guess just pull the card out of the way because I won't have clearance for the card there. or further back some when I did that. Okay. So that gets us a mounted board. We need to make sure that we get our hard back in there in the slot and that we don't move this now. And it looks like right now on this, we should have enough room to just bang past that. I do want to move this down. Once again, I'm going to be bringing power and bed power over here. Or no, I don't even need to bring bed power. I just need to bring power into this. I'll bring motor power into it as well. We will bring our motors up and put them in the appropriate sequence, in which case it's going to be, I think, BA and then the 4Zs. Take a quick look at the wiring for a 2.4. Just on the wiring order. I do have a Wego set, and I do have the rear piece for the plug-in. And it's really weird because that plug goes smack dab right in the center. So this piece will kind of go in and mount this way. This will mount here. Our switch will be right here. So that's where I'm trying to figure out, like, where am I going to put my Wagos? I may have to put my Wagos here and my SSR forward of where I'd want to, just to be able to get things to go in there. So yeah, we'll work on that on the next stream. Right now it's 9:30. We've got an ad break going on. But for those of you that can hear me, let's start figuring out a potential raid target for this evening. I'm gonna have to go to main Twitch just to see who's on. We have Creatix Brit, Babe Ross, Science, Astro Canucks on. Does anybody have a suggestion on a raid target for this evening? I was thinking about that, Darth Gollum. I was thinking about that. Nope, nobody has a suggested raid target. Um, what is Brit up to? She chatting with anybody? Looks like she is painting a project. Hmm. Yeah, exactly. Not many people on at the moment. So I'm going to go ahead and set up a raid over to Creatix Brit. Um, Create tricks, Brit. That works. Um, thank you everybody for being here with me today. Um, thanks for hanging out. Wiring wise, we're gonna I'll work through it, but I'm not going to do any more on this. This will sit here on the bench until Thursday when we come back to the project and do building. I am going to do some thinking. I'll say that much. I probably will mount the SSR in here, but I just really need to do some thinking on where and how things will go because this is a really compact build space. So thank you everybody for being here this evening. Um, go with me as we head on over to Raid Creatix Brit. We will come back Thursday and continue the wiring, finish our toolhead wiring, and get everything set up and ready to go. Like I said, all the software is already done and ready. So thanks everybody. Join me over at Brits, and I will see you on Thursday. Bye now. Ah.